Hello everyone, good morning. It's the same day as the last one, but of course, for you it's one day ahead. So, today we're going to try to figure out how we implement labels. There's a few things there that we need to build that are not trivial, so this is going to be interesting, I think. Um, let's get started with it. So the first thing is there's two kinds of labels. There's a label as an argument, and there's a label as a label, I guess. Um, now, this is interesting because we have the same syntax for both of them for good reason, because we don't want to like have confusing syntax. We don't want to have like jump hello, because then we end up with really ambiguous code. If we do like this, it gets a little hard to parse what the fuck is going on. Like this is a label, but the other ones are not. No good, right? So we're just gonna have colon syntax for both of them. And some languages, like some assembly things, they do this, right? Have a colon at the end. I don't find that to be such an interesting thing. I mean, you can just indent these if you need some sort of clarity here. It's fine. Okay, so again, still have coffee, so let me take a sip of that. Of course, if you're still here, you're still watching, make sure to subscribe. Okay, I'll give you some time to subscribe. Scroll down, do it. Um, hmm. So we do need to keep track of the offset of which instruction we're on. So every time we do get an instruction, we want to look at it. Oh, but we have the result, right? Quick recap, our result here in the compiled instructions function is the array or vector that takes care of holding all our instructions. So every time we add an instruction, we push it. So so the label has a name and an offset, which is always 0, so we don't care. And then we have the rest. And so tail is rest, but also the name. So the label gets a. So we need to keep track of all the labels. Okay, so let's make a hash map of string. It's fine. Let's just use a string. String to 64, and we're gonna make a hash map here. So hash map of labels holds all the labels and their real offsets. So we might have to do two passes here because we might not know a label. Because like, see, you can do blah label here. We try to jump to it here, can't resolve it, fucking dies. So need to make sure that we do two passes here for this. So we need two loops effectively. We need one where we resolve. Let's do a separate loop then, because let's do a separate loop. We basically want this exact same loop. And maybe we should factor this out. Let's do that. So collect labels. Actually, because then we have the problem of not knowing which instruction we're on. Because we basically want to copy this logic. So maybe we want a different type here. Maybe we don't want an instruction. Oh, maybe we don't want an instruction here because we want instead an abstract instruction. And this is the same approach I took in the original one, I think. So let's do that. So there's an abstract instruction which has a value and So the value is either an I64 or string. Oh, fuck. Let's think about this. We want to be able to store a label such that we can resolve it later. So this is only valid for all instructions that take a label, which is only jump, like all the jump instructions. So for all the jump instructions, we basically just want to store, instead of storing an I64, we want to store the name of it. Right. How do we do that without it being really ugly, though? Do we say we just have an enum, like another fucking value enum, and we have like int, and then we have one that's not an int? We might need that actually. Let's think about this. So yeah, we might actually need that because we want to support multiple types later, but then we need to implement completely different stuff anyways. I just implemented the type stuff last time, or the time before last time or whatever, the type checking and stuff, because we will have strings and stuff like that. Of course, we don't yet have instructions that can support that sort of thing. But I think it would make sense to go with this abstract value, which is basically just an op. What do we call it? Did we call it op? No, there was another one. Did we not use it here? I swear we did. Oh, we didn't. Did we implement types? Yeah, we did. Yeah, we did. Oh, yeah, on the stack. Yeah, on the stack we have operands, but they're part of the VM, right? Yeah, value. Okay. Okay. All right. So we want the same thing, basically, but abstract. So we have a integer A64, or we have any number of other types, or we have a label. Okay. And then the value is actually a abstract value. So instead of making instructions, we make abstract instructions. Abstract result. And then we can do this. Then this is not so bad. Because instead of doing this, we do abstract instruction, value, and what do we call abstract value integer? 0. Well, in this case, we can actually have one called none. I just use that here because that's a little bit cleaner though. And then here we can use abstract value integer. I'm jumping all over the place here, so. And then of course we want to transform it in some way to turn into real instructions because the result is still real instructions. But then we can do the second pass without having to worry about having to sort of make a concrete instruction out of labels, which we don't obviously want to do. So, and this is important too for the optimization pass later because we're going to do some operations on this abstract instruction. It's a little bit like an abstract syntax tree, right? if you want, if you will. So, okay, so we do want this, but of course without this, and of course we want to not have op. We want to have label. And I don't think we need this. I think that was a bad idea because we're not going to use that offset anyway. So label string. Okay, so this is the name of the label. Of course, we want to avoid having the possibility of declaring it twice. So we probably want to check for that later, but not right now. And okay, abstract instruction is that it's the op, old op. Let's see. We don't actually want, fuck. This is difficult. Let's maybe change this. So instead of, so there's two types of abstract instruction. We need to sort of do some other stuff here. So there's two times. There's a instruction, which has an op and abstract value. And then there's the label. Yeah. And we still want the abstract value because we will have other data types later. But right now we don't care. So instruction, label. We get that. We get that. And of course it doesn't know what the fuck this is because it can't find op, because it's not a thing. I meant to put it here. Okay, and then this is an abstract label. So we're basically building a syntax tree, right? It's just that our syntax tree is fucking flat. We could change that, but since we don't actually have if-else stuff, it doesn't really make sense for us to go too hard on that. Conversion. Yeah. Okay, and this one becomes the abstract instruction. Where we have a up and a abstract value integer. You'd like that? That's crazy. Okay, and then we have the second pass. Of course, label name. No, not quite right yet. The abstract value can be a label. That's a different use case. That's the use case where this is a thing that has a label. So if this doesn't match, then whatever we do match there, let's go to the instruction job thing. So this is anything bigger than push, right? So anything bigger than push is going to result in a jump. So these are jumps. But of course, these don't match because token value is not token label, so we don't care, right? So these are not going to match jumps, even though they satisfy this condition. They're not going to satisfy the match. Then the jumps will satisfy those. So And it's very well possible we'll be, you know, we'll get goofed up here, but this makes sense so far. So we translate the token label into an abstract instruction, a jump instruction with a label. And instead of doing this, actually, I don't think we want to have a label instruction. Yeah, we don't. So I need to undo this change again. I'm sorry. It's just, this is what programming is like, right? You just have to keep goofing around, and we do that later. Until it fits, you know, until you feel like it works. It's not so bad. I mean, you know, this is basically what the entire job of programming, for me at least, looks like. It's just trying stuff out, seeing if it works. And sometimes you try out more, sometimes you try out less, of course. Sometimes it's really clear what the solution is, like it was so far in this series, but I'm starting to get into territory where, you know, I have to think about it a little bit to figure out, oh, what do I want to do? How does this work? Because I haven't done that in a long time. Like this, the original MCL had the same problems, of course, and I think we came up with a similar solution, but there's no series on that, so don't worry about looking that up. Yeah, see, we're already at 16 minutes. Good thing I didn't make it part of the other one. Okay. Labels. In this case, we want to actually return error. Where we say that the okay, and then name and value is abstract result length, not -1, because oh, does it not like that? Oh, right, because we can't use length -1 because we actually want the address of the next instruction, right? Let's insert name address of next instruction. That's what we're inserting. So that's why it's a len. Its address is the same as the offset in this case because our program counter starts at the beginning of the code. Blah blah blah. Okay, and then we want to loop over the abstract result and replace any abstract instruction that has a label value with the actual offset of that label. So let's do that. Well, actually, is it map? Yeah, it is map. Or is it map? There's probably like for each. No, I think map is correct. Okay, so we take an instruction and we give it a match, right? So if let inster abstract instruction, let's actually use this. So up, don't care about the up value. And the value is actually not any value. We only want abstract value label. Oh, but we can't do that here. Oh, oh. That's how you do that. This is how you ignore it when it's like that. I always forget that. Okay, so we match that, and in that case, we actually want to return a abstract inster that has up, up. Oh, can we change value? Yeah, this gets ugly. Let's just make a new one. So we got our output, got our value. Our value has to match the abstract value label. The name. Can't do that? Why not? Oh, same mistake. It's a struct. Okay, and then we want to actually return an abstract instruction, a new one. Let's just make a new one where we have the up there, and then the value is gonna be abstract value integer with the actual offset. So let's check that we have the offset. And the offset's gonna be no. I want to be able to bail out of this, so I want to be able to bail. Oh, that one's not closed. Yeah, it's not closed. Anyway. There we go. So we got our instruction. Of course, we don't do anything in the else case. Shit. The else case doesn't do anything. And of course, if let the instruction, and then we set instruction to be that. Okay, so we replace the instructions. Actually, we can replace the instruction value with just the value, integer value. I'm goofing around a lot right now. So this integer is going to be the offset is this is the default case, right? The label exists. We put it in. That's it. And that's all. But in the else case, we want to return error, where we say label is not defined. Sick. Okay. Let's Start the semicolon. Oh, are we missing one somewhere? Not entirely sure what it wants from me. Oh, return. Can't fucking spell. Okay. And then we wanna concretize the instructions. So we want to turn them from abstract instructions into real instructions. Let's actually label this. So this is gonna be the resolve labels. And this is gonna be concretize to real instructions. Okay. For that we can use a map though. I know that. Because we only have the so there's going to be optimization steps, right? Optimization steps will replace parts of the abstract instruction with like other instructions and so on and so forth. 26 minutes. Okay, we don't care right now. It's a bit too much to worry about. So let's just get on with this. Inner map. Insta. Oh well. For Insta. And then this is just gonna basically convert them. I'm doing it like this because in case we want to do something else with it. Okay, so the abstract instructions match. Well, we basically just may make an instruction where the op is abstract instruction op, and the value is abstract instruction dot value. Where either it's integer, where we want to actually have the integer, and in all other cases, we at this point this shouldn't happen. So let's panic. It should never happen. Non-abstract value and concretization step. Because at this point, we should only have ones with integers, right? Because the only possible thing is that there might be a label, but the label has been replaced in this step, right? So if we fail to somehow replace that, then we want to panic because there's no way. I mean, we could return error, I guess, but right now we're saying that's impossible, okay? Because it's program error, I guess. So we can worry about it later. Oh man, okay, that was a lot of code. Now let's see. Let's see what happens if we do. If we run this. So now if we go back to our test code, we use labels here. We use the hello label. And let's actually print a little bit here. Just for the fun of it. Let's start printing a little bit. Well, let's see what works first, of course. Non-abstract value and concretization step. Okay, so we did fuck up. We did fuck up. Let's see. So I'm assuming we messed up here. That is immutable. That's not the problem. Let's print it. There's very few things it could be. We have a push. Oh, or none. Of course, of course. It can be none as well. In which case it's 0. Yeah, okay, that makes sense. Okay. So it should really never happen. That was just program error. Okay, and now it works. So let's only compile and let's see what we get. So what we get is first we get label hello and then a jump to label hello. This is only the tokens. When we build our abstract syntax tree, which is just fucking one-dimensional because we don't have branching, like not really, where we say, okay, we have abstract instruction push with integer, we have increment, duplicate, print, all of which do not have a value. And then, of course, we have an abstract instruction for the jump to the value of integer 1, because this is still after the step where we replace the labels. And then we concretize these into actual instructions where we have the jump 1. So now, of course, if we execute that, it does run and it counts pretty fucking high. So that's cool. I like that. So let's do let's also print it before we resolve the labels just to see what happens. So before we resolve them, the jump is to hello. After we resolve them, the jump is to 1. And it's 1 because that's correct. But of course, let's say we have the, we use it before we actually declare it, right? Like this. So this does the same thing as the other one. It does one sort of loop iteration manually for no reason. Stupid code, but bear with me. We then jump to hello, which at this point is not known. So this is why we have 2 passes. We could have otherwise just done the label in the first one just by taking the length of abstract result as the jump offset. But we want to be able to say, okay, jump to hello, and then hello is here. Because so it happens later. So we parse this, we do this, we then declare it, and so on and so forth. So that is what we want. And it still works. Because what it actually does is it figures out, okay, we do these, and then we jump to 5. And then we do these, and then we actually jump to 5 again. So it's 5, of course, because the offset of this is 5, because 0, 1, 2, 3, 4, 5, because this doesn't count. Okay, so that seems to be working very well. Yeah. Let's see. Oh yeah, I wanted to print some more information. So we should actually look into a debug library, like a logging library, not debug library. But I think we'll do that next time. I think we're good for now. Make sure to subscribe and like the video. Very important steps. Make sure to turn on the notification bell because I'm a small channel. Not sure if my stuff will get buried under other content if you don't enable it. So enable it so you get notified when I upload. You don't have to check. Did you upload? Did you upload? You just get notified, which is awesome. Very cool feature. And let's quickly implement labels on jumps. And that's it. Thank you very much for watching, and I'll see you in the next one.